live to Twitch, twitch.tv/smashamash for our Cosmology segment. Thanks to our followers over there on Twitch. Also, thanks to our YouTube subscribers. Don't forget to check out our other videos at youtube.com/smashamash/playlists. You may see other content that you were not even aware of. If you haven't checked out smashamash.org presents The Sun Part 16, check out the whole playlist. There is some spectacular imagery over there. Thanks to our YouTube subscribers. Thanks everybody who has answered the poll on our Twitter, twitter.com/smashamash. You've only got another 9 hours left to vote on who's more important, Vladimir Putin or Joe Rogan. And of course, after this poll is complete later today, I will explain who I would have voted for. Twitter.com/smashamash. Answer our poll about who is more important, Vladimir Putin or Joe Rogan. By the way, don't forget to check out our own website as well, smashamash.com. One of the links you can find there is the smAsho merch link. We've discounted all of the products at our Redbubble shop through the month of June. So if you haven't checked that out, again, you can find the links right at smashamash.com on the homepage. Smashamash.org will redirect you to this page. There are 7 designs there, so go have a look. And again, do not pole vault the caldera. Welcome to the Neo-Renaissance, and let's check out today's Cosmology segment. Allow me to get off the screen, as today's Cosmology segment starts out with a spectacular view of a galaxy. This is NGC 691. NGC 691 as imaged by the Hubble. Great view of that galaxy. And you can find an article about it here on phys.org's Astronomy and Space section. The Hubble Space Telescope. It's decades old and still not letting us down with spectacular galactic imagery like this great spiral galaxy with dozens of spiral arms. By the way, welcome to the brightest 24 days of the year, or if you're in the southern hemisphere, the darkest 24 days of the year. As we count down to the solstice, we'll be streaming live at 11:32 p.m. and 9 seconds. That's Eastern Daylight Time. That's the exact moment of the solstice. We want to be the first channel to wish you a happy summer. Today's random object is number 137 at the Neil Gorell Swift-Bat X-ray Observatory, which coincides with quasar B0420-127. Here's some imagery of that in the ultraviolet light spectrum from the Galix. Does it show up in X-ray? And indeed, it does not. How about on the 2MASS? So we showed you ultraviolet. There is the infrared spectrum. Here it is on Pan-STARRS in optical. It's quasar B0420-0127, which again is entry number 137 at the Neil Gorell's Swift Burst Alert Telescope. Here are the X-ray transient output. The X-ray output over the past 16 years and over the past 30 days. You can see it's got quite a bit of variability, but on the long scale, it's a fairly consistent X-ray source, that quasar, otherwise known as quasar J0423-120. And you can follow your favorite objects over there at the Neil Gorell's. For example, if you want to check out Sagittarius A star, just type in SGR space A, and there's the core of the Milky Way galaxy and its X-ray transients. And check it out, we actually saw a big burst from Sagittarius A star, a big X-ray burst there, which would be well off the scale. That would be 0.2. And you can see this scale here. In other words, that transient X-ray burst would be way up here off of the scale, off of the screen indeed. So one significant outburst there from Sagittarius A star. We just discovered it accidentally to demonstrate how to navigate the Neil Gorell Swift Observatory. By the way, a star's rotation is completely associated with its output. So its X-ray flux and its rotational period are totally related. Here's a quote from an article we're about to cover. Bouma has spent years developing the tools to measure a star's rotation so that he can calculate its age, a technique called gyrochronology, from the Greek words for spin and time. Our sun, which at the age of 4.6 billion years is in its sedate middle age, rotates once every 27 days. The stars Bouma measured in NGC 2516 are rotating 10 times faster because they are so much younger, or believed to be so much younger. Those stars are barely out of their infancy, only about 150 million years old. What we're talking about here is NGC 2516, which is an area inside the Milky Way galaxy where there's a string of stars. And this is one of the New General Catalog objects, rather. And
this is the open cluster.
Here's some imagery of it. And open clusters are interesting in that they're sort of sub-galaxies inside of the galaxy. So when we zoom out on this and we view it from a different... There's the Large Magellanic Cloud, by the way. When we view this using some different data, we can see that this area consists of a long string. You can see that long string of stars there. Those all look like they're related. There's this arc sort of a feature to it. And that little smudge there, those stars are all related in that they all have some similar characteristics. Now you're looking at the Orion Nebula, just to give you some idea of the scale of this. It's NGC 2516, a stretched out globular cluster located at about 1,600 light years inside the Milky Way galaxy. You can find this article on phys.org's Astronomy and Space section. Stream of stars extends thousands of light years across Milky Way galaxy. I'll let the article scroll here. If you'd like to pause the video and read the article, feel free. Again, it's on phys.org in the Astronomy and Space section. Let's talk about hydrogen and star ratios. There seems to be a relationship between the age of galaxies and the number of stars. Why is it that older galaxies seem to have a lot more gas than younger galaxies, which have a lot more stars and a lot less gas? Well, it suggests that the stars are hoarding the gas. I won't say too much about this one, but another interesting article here about star formation. Last year, we reported the first measurement of the atomic gas content in such distant galaxies, and we're talking about galaxies that are 8 to 9 billion light years estimated distance. With the present result, using a completely different set of receivers and electronics, we now have two independent measurements of the atomic gas mass in these early galaxies. This would have been hard to believe even a few years earlier. So this 21 centimeter radio signal is telling us how much hydrogen gas there is in these ancient galaxies. So perhaps have a read of that also. A very interesting article on cosmology here. An indication that older galaxies have a lot more gas and a lot less stars. Another article here from phys.org's Astronomy and Space section. And here's NASA's astronomy picture of the day. So we show this most days, and we're going to actually do two different things here. Thanks for leaving a comment. One audio. Good morning to you as well. So here's a fantastic image of Jupiter, and this is from the Juno spacecraft back in 2017. And we're going to show you an even crazier view, an animation of this. So this is from its 6th pass. Let's take a look at its 16th pass. Some spectacular imagery of the largest planet in the solar system as Juno makes its 53-day highly elongated orbit around the gas giant Jupiter. Most of those bands are made of helium and hydrogen gas, by the way, folks. And the light-colored ones represent upwelling. The dark-colored ones represent downwelling. The Great Red Spot is an anticyclone, a high-pressure zone, not to be confused with what we would call a storm on Earth, is typically made of a low-pressure zone. Anyway, great view there from Perijove 16 as the Juno spacecraft passes Jupiter. Just fantastic imagery. And last but not least, let's talk about annular eclipses. That's what you're seeing right there. That's an annular eclipse, not to be confused with a total solar eclipse. And on Thursday, we're going to see an annular eclipse. So don't miss that if you're in any of the places that are able to see it. This is an article from SciTech Daily, and it's a great little resource for you if you want to read more about annular eclipses. It's when the moon isn't quite perfectly in between the sun and the earth. Here's an animation of where the shadows will be. And the annular eclipse will go actually right to the Earth's geographic North Pole. Interestingly enough. So this is also showing you the time here. And you can see that annular shadow stretching across. There's another great diagram of that, where the annular eclipse will be best viewed. And it also talks about ways of projecting the sun using a pinhole projection process like a cereal box. Or if you've got eclipse shades like we do, perhaps go out and view it using those. Don't look directly at the sun. Don't look at an eclipse directly, as plenty of damaging radiation could make it to your eye anyway. And we don't want that. And that's today's Cosmology segment. Thanks for tuning in. It's time to say goodbye to Twitch and get back to the daily space weather.